Anyway, chaotic week coming up here. Let's see. This is not an A day. It should be a B day. But let me double check. I know our new updated AB calendar. We've had 3 A days in a row. Surely this is a B day. Hopefully they've updated the calendar because that's what I'm pulling up here. But yeah, let me change that. Okay. Yes, a B day Friday this week. So that won't affect this class. We'll just meet today and Wednesday if you need to meet. I'm going to have the grade book updated today. So that way, when you do your grade checks tomorrow, you'll know whether or not you need to be here on Wednesday. So, but again, Friday is a B day. So if you're needing to contact me, I will not be here on Friday. This is the conference tournament for bowling all day Friday. So I will be out all day with the bowling teams at Fayetteville. We'll be down in Fayetteville bowling all day. So that will be, and then next week I'm going to miss some days too because the state tournament is next Wednesday in Cabot. So I will not be here most of Tuesday and all day Wednesday next week. But we'll cross that bridge when we get there. All right, we're missing like 4 people here still. What's today? The 29th. The 29th. We're getting right here to the end of January already. Yep, 29th. So, good stuff. Well, I guess anyone else coming in is just going to have to catch up with us because we need to get moving. Look at this week's lesson. Foundations of Programming. So if I go to the grade screen, gosh, I didn't get my 4.1 decisions. Fake student is getting so far behind here. So this was last week, 4.1. You should have had that turned in last night. That was just a 5-question or 10-question. I think it was 5-question. Multiple choice assignment. But this week we have more decisions. You'll see due February 4th, this Sunday, more decisions. So let's look at 4.02. The lesson for more decisions. All right, hopefully you have your program turned in from 2 weeks ago because we're going to have another program now, and you don't want to get behind the programs. Those are 100 point each. Your grade plummets when you don't turn in programs. So if you haven't got the last one done, get both these done this week. All right, the power of if. Not all decisions are one-dimensional. In fact, most decisions are complex, right? We make decisions every day, and a lot of them. Take going for a walk. If your walking path is closed, you can skip your walk or you can do something else. I was just trying to get to the school here this morning, and there's a major wreck just right here in front of the school, except down towards the stoplight to the south. And I got there, and there is fire trucks and police cars, got the whole intersection blocked off. I had to find a new way to get to the school. Things are much more complex. And the first couple of roads I tried did not connect. I couldn't get through. So if your path is closed, you can take another path, do some yoga, climb a tree, whatever you want. Just because the first part of your decision doesn't work doesn't mean you have to quit. You have options, right? So that's what I had to figure out this morning is my options. So we're going to learn if, else, and elif statements. And then we're going to use those to make decisions. So let's get into these if, else statements. So now we're going to talk about making multiple decisions. Last week was really easy. We did an if statement. Now we're going to add to that. With if statements, if the condition is true, you take an action. That's what we did looking at last week's assignment with the multiple choice. We learned about if this is true, then we'll do whatever's inside the if statement. If it's false, you don't do anything, right? If you win a race, you get the medal. If you don't, you get nothing. You don't get a medal. However, more often than not, you want to write programs that can handle multiple decisions. This is where an if, else, or elif statement comes in handy. So let's look at the if, else. With if, else statements, if the condition is true, you take an action. But if it is false, you take an else action. So if this is true, do this. Else, do this instead. Like if you win a race, you get a medal. If you don't win, then you just get a participation ribbon to say, hey, you showed up. It means nothing. Elif statements. Let's look at this. Elif statements allow you to check multiple conditions. And as soon as it finds one that's true, then that action will be taken. So if you come in first place in the race, you get a first place medal. You get a gold medal. If, else if, Elif, which is else if, right? If you come in second, then you get the silver medal. If you come in third, then you get the gold medal. Otherwise, you just get a ribbon to say you showed up. So that's multiple conditions. And a lot of times, that's the way we run life with multiple conditions. So depending on the programming you're writing, you want to use whichever decision statement works, the if else or the elif statements. So for simple decisions, you use the if statement. For two options, use the if else. And when you need more than that, then you use the elif. So here's a little chart that shows that little flow chart. So you have a condition, and perhaps if the condition is true, then we do whatever. Otherwise, we just go around that and continue on. That's the if statement. The if else says, if it's true, do this. If it's not true, then do this. So you have two choices. And that's perfect for an if else. If it's true, do this. If it's false, do that. And then the elif is like, well, if it's true, do this. If it's not true, then check this. Is this true? Then do this. If that's not true, then check this. If this is true, then do this. And if that's false, then we'll do this other thing and then move on. So that way you can just check multiple things in one statement. Well, not one statement, in one loop to see what's true. So let's get into using a little bit of this. So if else statements. Life would get pretty boring if you only had one option for everything. Right? That's why you got to make choices. If you want to play a game solo, you choose to play offline, or you can choose the online program, option. Python is a pretty easy setup for this with the if else. It uses Boolean logic to determine whether a condition is true. If it's true, it executes the block of code that follows the if statement. If not, it moves on to the else statement and executes that block of code. So let's take a look. Age equals integer input. What is your age? Okay, that's just a Python statement asking the user of the program to enter their age as an integer. No decimals. What is your age? So if age is greater than or equal to 17, then it will print enjoy the movie. Else, that means else means this is false. Your age is not greater than or equal to 17. You're 16 or less. Else, print please bring a parent or guardian. Obviously, this would be a program written for you to get into an R-rated movie, right? R-rated movies are for viewers 17 or older. Otherwise, you need a parent or guardian. In this code, you're asking the user to enter his age before buying a ticket to a movie that has age restrictions. So using the if statement is perfect for this because there's only two choices. Either you are old enough to go to the movie without a parent or you're not. So it compares the age with the number 17, uses Boolean logic to determine whether it's greater than or equal to 17. And if it is, it'll print enjoy the movie. Or not, or else, it'll print please bring a parent or guardian. So with if-else statements, this is important to know, Python will always take some action. It'll do something. It'll either do what's under the if because the condition is true, or it's going to do what's under the else because the condition was not true. It was false. So it's always going to do something with an if else. It's going to do this or else this. So one or the other is going to happen. So let's practice some if else statements. So here's our sample programs right here. So let's look at what they have. So this is the if else statement. So the first thing we do is we start our main function, define main function, and we have two variables, x that we set equal to 20 and y that we're setting equal to 30. All right, so now it says print facts about A and B. Now this is interesting because there's no A or B defined, but let's see what it says. It's going to print facts about A and B. If x is equal to, remember when we're checking with Boolean logic, we have to use two equals if we're checking to see if something's equal. If they're the same, it's going to print x equals y. If it's not, it's going to say x is not equal to y. There's only two choices. Either they're equal or they're not. So we run this program. This is facts about A and B, x is not equal to y. which has nothing to do with A and B. Their program has a flaw there. So we can either correct that and make it A and B, or let's just say facts about X and Y. Let's correct their program and run it again. There we go. Facts about X and Y. X is not equal to Y. I love it when the people that write the curriculum make a goof, because I don't think they were supposed to be like that. They were using last week's program with A and B, and they didn't change that. All right, let's look at their next example. That's just a very simple thing. Shows how the if-else works. Notice, we do the if statement, and then the else is indented the same as the if. Right? It's the same as the if. What's underneath the if has to be indented further, and that's what it will execute if the condition is true. But for the else, it has to be back at the same indentation level as the if. And then everything under the else that's indented further will execute under the else part of that. All right, let's look at our next example. Define main, show equals, so shows are variable, and we're setting it into whatever the person enters. Input, when is the movie, afternoon or evening? All right, so there's the two choices that the user is supposed to enter, afternoon or evening. If the show equals afternoon, if they said this is an afternoon movie, then it's cheaper. You get that matinee price of $5.50. Else, it'll be $8. So it doesn't even matter if they type evening. It's just looking to say, did they say afternoon? We didn't even check evening, but that's the other choice that the user has. So we're only saying, did they say afternoon? If they said afternoon, it's cheaper. Otherwise, $8. Print cost of tickets. So let's run this program. All right, is the movie afternoon or evening? Let's put afternoon. All right. Cost of tickets, $5.50, $5.50. Now let's type evening. We'll check both cases. Cost of tickets, $8. Now let's run the program and say, I don't know what's going to happen. I didn't type one of those two choices. It's going to charge $8. Cost of tickets, $8. Because all it checks for is show equal to afternoon. Anything else that you type is going to default to that else statement. Run program. When is the movie? Afternoon or evening? And I'm going to say falafel. So it's $8. The only thing that makes it $5.50 is actually typing afternoon. And with that, if I typed capital afternoon, I put in capital A, it's $8 because it's looking exactly for afternoon, no uppercase letters. Exactly. All right, let's look at slide. So that's something that can happen with your program. If someone capitalizes the A, it won't check for it. Slide number 3. Here we go. Oh, from random import. Random. So we're importing the random feature. We haven't played with that yet. So run the program, look at the output. All right. Main function. Flips. Here's we set a variable name called flips, and it's going to equal an integer. The user is going to enter the number of coin flips. All right. That's why it's an integer. We're not going to have 4.5 coin flips. They're going to enter a whole counting number, right? Enter the number of coin flips. So we're going to start out with heads equal to 0 and tails equal to 0. And we're going to make a for loop. For count the loop in range up to number of flips. That's how far it's going to count. Starting at 0 to however many number of flips they enter when they use it. And then we're going to create another variable called result random. All right, so this is the hashtag. So this is a comment. Everything after this hashtag is a comment. This generates a random number from 0.0 to less than 1.0. So basically between 0 and 1. When it creates a random number, it does a decimal number between 0 and 1. All right. So if the result is, remember that random number it's going to create. Every time it goes to this loop, it's going to create a new random number and assign it to the variable result. If that's less than half, less than 0.5, we're going to say that was heads, because that's half of the number, right? 0 to 1, 0.5. If it's less than half, then we'll say the coin came up heads. If it's larger than a half, it would have come up tails. So we're just creating a random chance that it's either heads or tails based on half of what could be. So if it's less than half, add 1 to the number of times that we got heads. Otherwise, which means if this is false, that means it's 0.5 or greater, then we're going to add 1 to the count of number of times that the coin flip came up tails. And after the for loop ends, right, if we say 10 here, if 10 is what we enter, after it gets to 10, it'll go out of the loop and stop looping, but it's going to go through here 10 times. Print a blank line, print coin toss results, print this exactly as it's in quotes. And then we're going to say heads with whatever number heads ended up and tails with whatever number tails ended up. So that's the end of the main function. Let's run this and see. All right, we said if we enter 10, let's enter 10 coin flips. And it came up 4 times that it was heads and 6 times that it was tails, which means 4 times that random number it generated was less than 0.5. And remember, it's going to be from 0.0 to less than 1, which means it could be 0.9999 or however many decimals it'll do that. And it came up. If we run it again, we might get a different answer. 10, let's do 10 again. Oh, now we got 8 heads and 2 tails. How crazy is that? It can happen, though. If we say run and flip it 500 times, it'll go through our loop 500 times. And this time it's 255 heads, 245 tails. It's a lot closer to 50-50. If we run it 5,000 times, still very close, only 22 off of being exactly half. Right, so this will just do however many times we want to say. Let's run it 1 million times. We run that loop 1 million times. That may take it a minute. There it is. It took it a moment, but 499,421 heads, 500,579 tails. Creating a for loop and using the random feature to do that. Now, random is not truly random. Computers cannot actually randomly pick a number. They have to write into the Python program how to choose a random number. And different programs do it different ways. Python does it differently than any other type of programming language. Fortran, C++, Java, any of those will do it differently. But usually, to create a random number, it would do something involving like the time. It'll look, what is the time this actual second? Oh, let's see. It is 7:35 and point however many milliseconds. And it will use that number and multiply it by some other number and just come up randomly. So every time you ask for a random number, it'll be different because the milliseconds of exactly what time this is at this particular moment in the computer processor is different every time. So that's the way of doing it, because otherwise computers randomly, they don't know how to pick random. It's all a process. So a lot of times it uses the actual processor time of your computer. So, all right, let's look at the last slide they have on this example, the if-else statement. Oh, we're going to import turtle. Okay, import turtle and define a function called draw face. T. So this function draws a face. So T, color yellow, T, pinup, T, set position. So our turtle is obviously a T here. Well, look at this, is a long program. All right. They're naming their turtle T, apparently. Yellow, pick the pin up, move over to 0, -30, put the pin back down. Begin fill, don't just make a shape, but fill in the shape, color in this circle that has this diameter. All right, so it's going to go to that spot, make a yellow circle, and fill it in. Begin fill, end fill. Now it goes to draw eyes function. So this function, when you called up this function, is going to draw an eye, make a blue pick up the pen, move over to this position, 30, 65, put the pen down. Again, fill it up, small circle, it's only 15 in the fill. Pick the pen up, move over to this position, put it down, fill that. So it makes both eyes, right? There's an eye, there's the other eye. And then draw a frown. This function draws a frown. Make it red. We want a width of 10, so with the little wider line. Pick the pen up, move over to this position, turn left 90 degrees, put the pen back down, fill it up. Here it is, this circle, infill. And then we're going to draw a smile. So we're going to have a frown and a smile. That's interesting. We're going to make it red with a width of 10. Pick the pen up, now move over here, turn right again, put the pen down, make another circle. Again, fill, infill. All right, so here's our main function. We're naming our turtle T, T.turtle.turtle. We're going to set his speed at 10, and we're calling this other function that we created up here. So it's going to go to draw face, 10. So it goes up and looks for, okay, where's draw face? Draw face. So it goes up and it executes this. Zoop. Then it comes back down to the main function. Then it goes to draw eyes. Now it'll go up and it'll call this function. So these are functions we've created. Define, draw, frown, function, basically. So this function draws that. So after it does that, it goes back to the main program. It says, okay, I want it, and I executed that one, then I executed that one. Oh, now there's an input statement for the user. Do puppies make you smile? Yes, no. Y, N. If smile is Y, where the person said, yes, they do make me smile, then we're going to draw the smile. We'll go up to that function and execute that. If they don't say Y and say N or P or any other letter because it's not Y, then it's going to draw the frown, and that'll be the main. So when we created this function, sorry, I didn't mean to scroll there. It's not going to do both of these. It's going to do draw frown or draw smile, depending on if smile equals Y or not. So let's run this program. All right, so it did the eyes. It hadn't finished filling that in, but do puppies make you smile? We'll say, well, of course. We'll type Y. So it made this little half circle that filled in and made a lovely little smile on the face that we drew. All right, let's run it again and say, no, of course puppies don't make me smile. I hate puppies. They're terrible. All right, do them. No. I'm going to put in no. So there you go. It's an upside down. It's a frowny face now. No, get those puppies away from me. Okay, I don't know if that may be a bit drastic, but you can see the choices. So this is a nice way to use an if statement to change the drawing. We can draw two different things with the exact same program by putting an if-else statement in the program. So there you go. Nice way to have two different things. Choice. If it's true, this. If it's false, this. That's it. Two choices. So go back and play with this if you want. Go back and, make sure you're going into the assignment, the lesson. Going to the lesson and play with these sample programs. If you get in here and you mess things up and it's not working right, let's see, I put it, it's going to be weird now because I did something wrong. Where'd my eye go? My eyes went somewhere weird because you can always hit restart and it'll reset it. We hit restart. Now it's set it back. I can go back to slide 4 and the program is back like it was started. So if you mess something up where it won't run anymore, you can always restart it and go back and change something else. So see how these things work by going in here and changing things. All right, let's look at the Elif statement now on page 4. So here's the thing. Sometimes you need more than two options. This is where the Elif statement comes in. Think of it as a combination of the words else and if, right? So if we have an Elif statement, you can get a wider range. So here's an example. Grade equals input. What is your grade? All right. And we should have given them some choices because they want us to enter an A, a B, or a C. Because if I say, what is your grade? I might put 92, right? That doesn't help the program. We should change that to say, what is your grade? A, comma, B, comma, C, comma, D, comma, F. Tell them what you're looking for in your input statement. But this says, if grade equals A, all right, I entered an A for my grade, print excellent. LF, which means else if, if it equals A, do that. Else, if it equals B, then do this, print good job. But if both of those are false, else, if grade equals C, print nice start, try to study more next time. Else, whether they enter D or F or anything else, it'll print please reach out to your teacher, right? So if it's A, it'll print excellent. If it's B, it'll print good job. If it's C, nice start, try to study more next time. Or anything else, reach out to your teacher. But there we have multiple options. All right. So here you've asked a user to input his grade. It'll compare either A, B, or C one at a time in that order. It'll look for an A first, B second. And if it finds a match, it'll stop and do the appropriate print statement. All right. If they enter A, if the user enters A, then Python won't check the elif conditions in the code. Once it finds this is true right here at A, it'll do that and then jump out of the loop. It won't check B and C if A is true. Right? If A is true, that ends the if statement. It'll print and then jump to whatever's after this. Once it finds something true, it won't go through the rest of the choices. So here's a nice breakdown. If this choice equals X, it'll do this if that's true. Else, if choice equals Y, it'll do that if it's true. Else, if choice is Z, do that true. And we could do 10 of these. It's not just 3. We could keep doing elif, 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 elif. We could do 10 of them if we need to. It depends on your situation, right? And then once they enter something besides X, Y, or Z, it'll jump down here and may do nothing. Maybe you don't have an else. Maybe I'm only checking these things. If none of those are true, just forget it and go on. All right, let's look at the sample program they gave us for this. All right, define main. Start our main program right here. We're going to set A equals to 20 and B equals to 10 and B equal to 200. Now this time we're actually using A and B and not X and Y. Print facts about A and B. If A equals B, then we'll print A equals B. Else if, elif, right? Elif's our command, but we're saying else, if that's not true, is this true? A is larger than B. If it is, then we'll print A is greater than B. But if neither one of those are true, let's check to see is A less than B. And we'll print A is less than B. And then if none of those are true, we'll say there was an error because either A has to equal B or has to be smaller, has to be larger. If none of those are true, there's an error because that's the only choices there are with two numbers in main function. Let's run it. This says facts about A and B. A is less than B because A was 10 and B was 200. So absolutely A is less than B. Let's change it. Let's make A 1,000 and run again. Oh, now it says A is greater than B. So this statement became true. So it printed this. Let's make them both 200. So we're testing all the features. Now they're both equal to 200. When we run it, A equals B. So the very first if statement was true. It printed that and then exited. All right, let's look at the next slide. Define main, print who won the game. Right, and your score is 9,520. My score was 9,905. So if your score is greater than my score, then you win. If your score is less than, I win. Otherwise, it's going to assume they're the same because that's the only choices. Either yours bigger than mine, so you win. My score bigger than yours, so I win. Or else they must be the same. It's just assumed. We didn't even check to see if they're the same. We just say, well, that's the only other choice. So run the program. Who won the game? I win because my score was higher than your score. So if we change your score to be 9920 and mine's 9905, you win. And of course, let's check that option whether they're the same. Both of us got 99.20. We tied. All right, so it's always checking, and once it finds something true, it exits and does not do anything else. We could add a statement here just to check that. Print the loop ended. It's not really a loop. Let's say the if statement ended. So whenever it gets there, it'll print that. Yep, we tied. If statement ended. I win. The if statement ended. See, it printed there, and it skipped everything else and went straight to the next command, which said to print. All right, next. The Elif statement. Okay, we're importing the turtle. Import turtle. We're going to define a function called sunburst. So move to this position. Take the pin up. We're setting the position as two different variables, 150 and 130. So it says, okay, it'll move to position 150, 130. Hashtag comment sets the position. Sets the heading at 270. So, which I think is down, right? Didn't it go right? But if we turn 270, it's going down. Puts the pin down, starts gold. Okay, that's what this sunburst does. Now for the star, hashtag draw star, it sets the position at x minus x divided by 1.75, y minus y divided by 12. So it's doing some math with these numbers, so it makes it pretty different shape. And it's going to do a loop that goes 40 times, right? For n in range 40. So 40 times, it's going to go forward 60 pixels and then turn left 130 degrees. Okay, that is the sunburst function. Then we're going to define another function that's a spiral twist. This function draws an eye, so it's going to change color to blue, pick the pin up, move to this position, put the pin down, and then do a loop from 0 to 75, counting by 2. So it's not going to execute 75 times. It's going to execute like 37. It's going to go forward whatever x is. The first time, it's going to go 0. It's not going to move at all. But then it's going to go 2 and 4 and 6. So that's why we counted by 2, because we wanted to move forward that number and then turn left 91 degrees. Okay, now we have another function called doily. This will draw frown, it says. Pin up, set position 45.5, turn left 90 degrees, put your pin down, and do a loop here. Just 2 loops. But inside this loop that it does twice, it's going to do another loop 5 times. So it'll do this loop 5 times, come back up here and do this loop 5 times again. It's going to green, T circle 30, T circle 20, T forward 20. Then there's another loop inside that's going to execute 5 times. 5 times inside there, it's going to do another loop where it does yellow, turns right 80 degrees, moves forward 5 pixels. Then goes back to this part of the loop 5 times. It's moving forward 40, left 36. So that's going to be a pretty interesting shape. This doily. I don't know why it says draws a frown. It looks like it draws a doily. But all right. Define. Here's print menu. Here's another function. These are all different functions that we're just creating. So this prints the menu to the screen. Print. Menu of turtle patterns to draw. If you put 1, we'll draw a sunburst. 2, spiral twist. 3, doily. 4, exit. Okay. Now, those are all the ones we defined. It doesn't run any of those. It starts with our main. This is where the program starts. It'll come down here. We got turtle.turtle. So it calls the turtle function. We set the speed equal to 10. It sets the choice to -1 because we haven't made a choice yet. Now, while the choice is not equal, there's that not equal. We haven't used that yet. The choice is not equal to 4 because when we choose 4 on the menu, that means exit. So as long as they don't say exit, then we want to do everything in this loop. So as long as it's not 4, print the menu, input, look at the menu, which item would you like to draw, and then with their choice, if they choose 1, then go up and run that sunburst function up at the top. We define that function. Go do that. If they say choice 2, Then go run that spiral twist function up at the top. 3, run the doily function. Otherwise, if they choose 4, just say thank you for drawing today. And then if none of those 1, 2, 3, 4 or something weird happens, there's an invalid option. Please try again. Like if they didn't choose 1, 2, 3, or 4. Now the problem with our Python is when we run this, we won't see this menu. Look, run. It jumps straight to the input. It's printed that, but it doesn't show it, and that's just one of the flaws of our version of Python. If you had a different version of Python, it would probably print that first. So it's nice to put these options in the input statement. 1, 2, or 3, and select 4 to exit. So let's hit 1. We'll hit 1. Here it is. It's doing the sunburst. Now we can see the menu after the first time. There's that sunburst. Oh, now it's back to the menu. Let's do a doily. Let's hit number 3. It moves to a different place. It's doing yellow and green. That's the loop within the loop within the loop. So it's doing this fancy. Okay. And then let's choose the other option, 2. There's the spiral twist. If we chose 1 again, it should jump right back to where it was and redo that shape. See, it's doing that again. If we choose 6, oh, we did 6. I don't know if I can see that then. Let's do 4 now and exit. Every time it printed the menu, print the menu, print the menu. There's when I chose 6, it printed oops, an invalid option was picked. Please try again. And then finally I hit 4 and it said, thank you for drawing today. So that's using the Elif to print different things based on what the input is from the user. All right, so you'll need to look at this program and see how they did that, because they define different things up here. Define spiral twist, define sunburst, but it didn't run those. Just because this is here, it doesn't run it. It's going to start with your main program. That's where it's going to start, main. Right, define main. And so it's going to do everything in here. And from here is when we're going to tell it to go up and run those other functions. Because notice, we could just run this program. Let's do it. Okay, let me restart it to clear out. Cancel. Oh, 4. I got to hit 4. Exit. Okay. Now it's empty. So let's run the program, and I'll just choose 2. So it'll just do the spiral twist. And then I'll hit 4, and I exited. Thank you for drawing today. Notice we never ran the sunburst of the doily. Even though it's in the program, we defined it. It was defined, but we never called it up in our main program. In our main program here, we never told it to go do that because it was never chosen from our menu. The if statement was never true. The choice was never 1 or 3. It was only 2 and then 4. So that's the only statements was executed. All right, well, let's look at our assignment then. And I have the template. Let's just go to the template, because if I follow in the assignment template, here's a rubric here if you want to see how it's graded. The rubric is right here in there. Program design, program content, performance, post-one review. So, but if we go to Buzz, it's just right here. You do your template, you choose it, choose the Google file right there. But in Google Classroom, you have this template. All right, 4.02, more decisions. The assignment has 3 parts. All right, here's part 1, programming. Write a program to move the turtle based on the user's request. Much like that example we just looked at, user's request is what caused the turtle to draw different things. So display a menu and use the following guidelines. Create a menu that gives the user options for moving the turtle. The menu should either have letters or numbers that align with movements like forward, backward, or draw in a particular pattern. All right, so you can say you want the turtle to move forward, move backward. You can do choices, or you can set up a function like our sample program did. It just does a whole drawing. You have to use at least one if, else, or elif statement. Right, that makes sense because this is a decisions assignment. So you have to use one of the if loops. and it should be used to move the turtle based on what the input statement was. A loop is optional, but you may need it if you're going to draw something with turtle. You may need to use a loop if you're doing spirals or whatever. Use one color other than black. You can use black, but make sure you use another color also. And write your pseudocode, right? Put your pseudocode right here. All right, put your pseudocode, what you're going to do. Here's part 2. Now write the actual code. Make sure you have the heading that has your name, date, and description of the program. Make sure you indent things properly and use meaningful variable names. So here's a sample. Someone wrote a program that says, try to move the turtle into the pond, and they gave this choices. If you use F, it moves forward, B, it moves backward, L, it turns left, R, it turns right, and Q. And so the person would have to hit input to move the turtle around the screen, like do it forward, left, forward, right, forward, and finally got it inside. So they made a little pond and turtle game. So that's just a sample of what someone has done to write this program. All right, so put your program right here, right? There's your program. And then answer the question. What was the purpose of your program? How could it be useful? What's the problem you ran into? What's something you do differently next time? Same questions that we usually have are postmortem review questions. All right, postmortem review questions. I'll highlight that and make it bigger. But there is your assignment. So you definitely want to go into the lesson. You want to look at that page 4 examples. Don't copy page 4 exactly. I know how to do the spiral and the doily and all that. So you need to do something different than drawing a spiral and a doily and all the other stuff it did on here. But this is a good sample. If you need help figuring out how to do it, go back to this and see how they did things. Oh, they imported turtle. They defined a function. So you can define a function, name it whatever you want, and have it do whatever you want it to do with the turtle. And then do a different function. If you just want to give 2 choices in your menu, that's fine. Because you'll have an if-else statement and all that good stuff. And so when you have your main function is where you're going to put your choices, your input, and your if statements and elif statements. All right. You don't have to have 4 choices. You can have 2. So there you go. That is the assignment this week. Get started on that early, because if you have trouble, I'll be in class Wednesday. You can come Wednesday and say, okay, Mr. Brock, I'm working on this. It ain't working. Can you help me? Yes, I'll be happy to help you. Or, of course, you can also copy all your code, email it to me. But there you go. So for anyone new in the class, just because we do have some new folks, when you're writing your program in idle so you can test it and all that good stuff, make sure in the lesson you're using this idle button right here, idle. And that opens up the window where the Python program can be written. So make that bigger. Right there. There's where we write our code, and there's where the output is after you run it. So there's where you write, and you highlight all that and copy it and paste it into the template when you're done with it. Don't do this save. That doesn't work. For Buzz, does not save it. That does not work. It creates an empty file. It does not save your code. So use that idle, copy and paste. All right, guys. That's it. That's all I got for you today. That's plenty, though. You can have some fun with this. You got more options on how to do things now with the if-else statements, not just an if statement. If else, we can create multiple choices. So have fun with it. If you got trouble, let me know. Get this figured out. If you're behind some assignments, get those turned in too. It's early in the semester. You don't want to start piling yourself up with zeros. So, all right, guys. Have a good week.